Our last section from this first unit is section 2.4. So we've talked about, if you remember, in chapter 1, we talked about solving linear equations in one variable. And then in section 1.5, we talked about solving linear inequalities in one variable. And then we jumped to chapter 2, and we're doing the same thing, but now with two variables. So we've spent these first three sections talking about linear equations with two variables, and now we're going to finish up this unit with linear inequalities in two variables. So same sort of thing. So a linear inequality in two variables can be written in one of these forms. And so we've got our ax plus by. It could be less than c or greater than c. Those are my strict inequalities. Or it could be less than or equal to c or greater than or equal to c. Those are my weak inequalities. Again, you're familiar with that. That's nothing, I think, novel or earth-shattering. And then the other thing to know is a, b, and c can be any numbers at all. And then a and b can't both be 0. Because if they're both 0, then you've got a lot of nonsense going on. All right, so what we're going to spend our time doing today is we're going to graph these inequalities. Now, this is a great section because, again, I teach this assuming that most of you are going to take college algebra. So when you get to college algebra and you have the Perkster in the spring for college algebra, it's going to be an amazing experience. We will graph inequalities of every single equation that we graph. We go beyond linear equations in that class. It's so fun. Okay, it's going to be the same exact steps. So get to know them now, because you're going to use them. If you take college algebra, you're going to use these steps over and over and over, pretty much every unit. So here we go. Example 1, we're going to graph the linear inequality. Negative 5x plus 2y is greater than 4. Okay, that's what we're going to graph. There are 3 steps to graph any inequality. That should be any, okay, typo, big fingers. There are 3 steps to graph any inequality, whether it's a linear inequality or a quadratic inequality or a rational inequality, whatever you're graphing, it's the same steps. So step 1 is we are going to graph the boundary equation. We're going to graph the boundary equation. This you already know how to do. Step 1, there is absolutely nothing different than what we've been doing. So this is good chance we're going to get a whole bunch of time to review graphing our equations. So what do I mean by the boundary equation is I'm going to take the inequality that I've been given, negative 5x plus 2y, and I'm just going to put an equal sign in there. Okay, this is my boundary. So we've done this. We'll keep doing this. How do I get this negative 5x over to the right side of the equation? I'm going to add it. Yep. So what I'm going to do is I'm going to put this in slope-intercept form. So I've got 2y is equal to 5x plus 4. We divide both sides by 2. And I get the equation that y is equal to 5 over 2x. And then 4 over 2 is plus 2. If you're not comfortable doing that, please talk to me about it. Okay, let's ask a question because you're going to do that a bunch on the test. Okay, it's right there. So now, again, this is just review. Sorry for the repetitive questions. What's the slope of that line? Yep, well said. And what's the y-intercept of that line? Okay, 0, 2, sure, 2. Okay, that's all the information that I need to graph. So I'm going to go ahead and do that now. If you're ahead of me, make your dots, don't connect the dots. Okay, so I want you to stop before you connect the dots. So 0, 2 is my y-intercept. I'm going to make a nice dot right there. And then my slope is 5 over 2. So that's up 5 and then right 2. It's in positive in both directions. So up 5, 1, 2, 3, 4, 5, right 2. If I do that again, which you're welcome to, I got to guesstimate. So I'm going to get a third point by instead of going up and right, instead of going positive both directions, I'm going to go negative in both directions because a negative divided by a negative is positive. Don't connect the dots. So 85% of the work of graphing an inequality is stuff you already know how to do. Okay, very little new stuff. Are you with me so far? Are we doing okay? Okay, so now step number 2, again, no matter what kind of inequality you're graphing, we're doing linear ones. How am I going to connect the dots? Well, you've got a choice. We are either going to use a solid line or a dotted line. Okay. And I just want to take us back in time. Okay, this is when we were together in section 1.5, and we talked about graphing stuff on a number line. So you don't have to write this down. I'm sure you've already got it. I'm just going to find some room up at the top. When we graphed x was greater than 5 on the number line, first thing I asked you is, what's the boundary? Because we had a boundary there. Boundary is 5. Then what did we put at the boundary on this particular inequality? Open circle. Why did we open the circle? Because there's no equal. Great. Okay. So that was our choice. And then we graphed x is greater than or equal to 5. Well, again, 5 is the boundary. That time, what did we put at 5? Solid, because 5 is included. It's equal. So we put a solid dot. Well, that's analogous to the choice you have to make now. So when you have a strictly greater than in our linear inequality with two variables, which do you think we're going to use when there's no equal? The dotted line or the solid line? The dotted, because the line, even though it's the boundary, is not included in the solution. And when you have equal, you're going to use a solid line because the line is included. So that's how you make your decision. There's solid when you have equal. So I'm just going to put in parentheses when you have the equal, okay, or the weak inequality. And you use dotted when there's no equal sign, or you have the strict inequality. So for my problem right here, my example 1, how am I going to connect the dots? What am I going to use? Yeah, dotted. Thank you. There's no equal bar, so I'm going to use a dotted line. So I'm going to do my best. So here we go. Dot, 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 dot. Oh, that's beautiful. There we go. That's the dotted line of the year. Love it. So far, we so good? You doing all right? Now, the last thing you have to do is, since it's inequality, again, thinking back to section 1.5, when we did this, after we determined what we put at the boundary, we shaded one way or the other because the boundary divided the number line into two halves. And so for greater than, we shaded this way. And so for the number line, the decision was nice and easy. Don't shade yet, because you cannot just assume that greater than is always going to mean above or left. Okay? I can change one sign in this problem and you would shade the other side. So what we have to determine is, where are my solutions? Are they on the left side of this or are they on the right side? And the way we're going to make that determination is we are going to shade. And then first we are going to pick a test point. And the only thing you have to remember about the test point is it's not on the line. So what you're going to do is you're going to pick a representative either on the left side of this or on the right side of this. That representative is going to represent the whole population of points on either side. It absolutely does not matter which point you pick. You can pick anything. Now, you know, you've been in my class a couple of weeks. I'm fundamentally lazy. Okay, so if I'm able to, I have a favorite test point to plug in. Anybody have a guess? Yes, you get me. I love it. Okay, we're going to plug in. My test point is I'm going to pick 0, 0. I'm only picking that because I like to plug in 0. You could pick 5, 0 or 5, -7, or you could pick -10, 18. It doesn't matter. Just your test point can't be on the line, and 0, 0 is not on the line. So notice the tip of my pen. That's where the test point is. So either that test point is going to be a solution or it's not going to be a solution, and that's going to tell me where to shade. So let's see. So I'm going to take the 0, 0, and now I'm going to put it in the inequality up here. So I've got -5 times 0 plus 2 times 0 is greater than 4. I'm going to just slide this up for the moment. I'll slide it back down when it comes to the shading. I want everybody to see my work. Again, why am I picking 0, 0? Because anything times 0 is 0. So -5 times 0, that's 0. 2 times 0 is 0. I have 0 is greater than 4 when I plug in that test point. Is that a solution? No, it's not true. Okay, so this is false. I'm going to write the word false right here. So who can help me with my conclusion? So here's what I've got. Where my pen tip is, that's the test point. It is false. It's not a solution. So where do you think I'm going to shade then? I'm sorry? The opposite side. Yes. The solutions then are over here. So here's my very intricate advanced shading. Those are my solutions. Now, if you don't feel confident, pick a point over there. Pick -4, 3 if you want and plug it in. You will get a true statement. So if you were working ahead and you picked a test point over here on the left side of the line, then you, when you tested it, got a true statement, and that the true statement says, okay, I'm on the correct side, and you shade there. Sometimes that's hard for students to discern why I shaded where I did. Does anyone struggling to understand why I chose this side to shade on this problem? Yeah. Okay, so 0, 0, let me use a different color. 0, 0 is right here, it's purple. Okay, that's the test point I picked. Does that make sense so far? You see where 0, 0 is? Okay, so when I plug 0, 0 into my inequality up here, this is the relationship. I want to know where are the x's and y's, that when I plug those x's and y's in, I get a value bigger than 4. When I plugged in 0, 0 down here, I got 0. I got a value, is that bigger than 4? No. So what that says is any point that I pick on this side is going to give me a value that's not bigger than 4. So these are not the solutions. If the sign was less than 4, then this would be the side I'd want to be there. And so that tells me, okay, where this purple dot is, that is not the side I want to be on. I got a false statement. So let's go ahead. You don't have to write this down if you don't want to, but I just want to show you what would have happened. So let me do this. Let's pretend. So we're in the land of make-believe. Let's pretend that I had tested -4, 3. So again, I'm going to put a purple dot there. So 1, 2, 3, 4, 1, 2, 3. I'm going to test this point right here. So let's see, would I get true? Is that the right side? So let's go for it. So now I'm going to put that into my inequality. So I've got -5 times -4 plus 2 times 3. And I want to know, is that greater than 4? Is that a true statement or is that a false statement? Well, -5 times -4 is 20. 2 times 3 is 6. And 20 and 6 is 26. Is that a true statement? When I plug in -4, 3, do I get a value that is bigger than 4? Yes, clearly. That's how we make that distinction. Is that helpful? Is that a little better? All right, well, you're going to do a couple. So if it doesn't come into your brain, we'll see. All right, so here's what I would like you to do. Exercise 1, do your 3 steps, graph the boundary, determine if you're going to connect the dots with a solid or a dotted line, and then pick a test point to shade. And I'm going to get started. If you're working, keep working. There's no shame in continuing to work. Everybody works at a different pace. Okay, so exercise 1, I'm going to go through my 3 steps. If we diverge somewhere, that is a great opportunity to ask a question. So step number 1 is I'm going to graph the boundary. So I'm just going to take 2x minus 3y equals 6. I'm going to solve that for y. So to get this 2x over to the other side, I'm going to subtract. By the way, if there's any questions on stuff like that, please ask. So then I have negative 2x plus 6 on the other side. Divide both sides by negative 3. And I get y is equal to, so I have negative 2 divided by negative 3, that's positive 2/3 x. 6 divided by negative 3 is minus 2. So from that, I see that I have a slope of 2/3 and then a y-intercept of 0, -2. We doing okay so far? This is the review part, but doesn't mean you can't have a question. Okay, so -2, I'll make a nice fun red dot right there at -2, and then my slope is 2/3. That means 2 in the y direction, 3 in the x direction. So 2 in the y, 1, 2, 3 in the x, boom. 2 in the y, 1, 2, 3 in the x, there we go. How am I going to connect those dots? A solid or a dotted line? Okay, this time I'm going to use a dotted line again because there's no equal. So a dotted line is going to be the order of the day. So here we go. So lovely. There's my dotted line. And then I'm going to pick a test point. You're not required to pick my test point. So anybody got a suggestion for me? 2, 2. Okay, so I heard 2, 2. So my test point's going to be right up here. So I'm going to test 2, 2. Wait, if you did 0, 0, that's great as well. Okay, so 2, 2 is my test point. So that's 2 times 2 minus 3 times 2. And I want to know, is that greater than 6? 2 times 2 is 4. 3 times 2 is 6. And 4 minus 6 is -2. Is -2 greater than 6? Is that a true statement or a false statement? Okay, that's false. So please note, whether you get a true or a false statement here depends on where your test point is. Okay, if you pick the test point down here below the line, then you got a true statement. You're on the solution part. If you picked something above, if you picked 0, 0, which is my default, then you got a false statement. So once again, I'm just going to make a little dot with a different color because I don't want you to think this is part of the answer, but my test point is right here, this black dot. I got a false statement where the black dot is, so that means where am I going to shade on my solution? Opposite side, yes. This black dot is on the false side, the not solution side, so that means the solutions must be over here. So here's my elaborate, very intricate shading. Question about that? Concern? Conundrum? Internal commotion? Okay, I really hope by this time, we've been together 3 weeks. I really hope that by this time you see that I like questions, I'm open to questions, I want them, okay? So I just want to make sure we're all feeling decent about this. I know it's hard stuff. I know there's a lot in this first unit. So do exercise 2, please. Same thing, graph the boundary. Determine dotted or shade, dotted solid line, and then pick a test point in order to shade. If there's something absolutely troubling you, raise your hand. Okay, so I'll come to you if you need me. All right, so once again, I'm going to get going. If you're still working, I'm not meaning to rush you. Just like if you're done, I'm not meaning to bore you. So get in the middle here. So first thing I'm going to do is I'm going to graph my boundary. So 3x minus y equals 4. So I'm going to get that solved for y. So I'm going to subtract the 3x and get negative y is equal to negative 3x plus 4. Divide by that negative 1. And I get y is equal to a negative 3 divided by negative 1 is 3x. 4 divided by negative 1 is negative 4. Slope, what's the slope? What's my ratio? 3. I'm going to write that as 3 over 1, if you don't mind, just so that I have a rise and a run. And then my y-intercept is beautiful. Well said. So 0, negative 4 is right here. My slope is 3. So that's 3 in the y, 1 in the x. 1, 2, 3 in the y, 1 in the x. Let's do it again just because I'm having a great time. There we go. There's my boundary. That divides the Cartesian plane into 2 halves. How am I gonna form that boundary? With a dotted or a solid line? Why solid this time? Because there's that equal bar right there. That equal bar tells me that the boundary is part of the solution. Okay, I want to know where these things are equal. So I will graph this with a solid line. So just like this. Yes. And then last but not least, I need to know which side of this I am going to shade. So somebody give me your test point. 2, 1. Okay. So again, I'm just going to make a dot there. So 1, 2, 1. Now you picked something really close, but that's okay. It's on the other side. 2, 1. It's on the other side of the boundary. It's, as long as it's not on the boundary, you can pick anything you want, as close or as far away. So 2, 1. And so here goes. I've got 3 times 2 minus 1 is less than or equal to 4, or I want to know if it is. So then I have 6 minus 1 is less than or equal to 4. 6 minus 1, oops, I was thinking ahead. Sorry, everybody. 6 minus 1 is 5, less than or equal to 4. Is 5 less than or equal to 4? No, if it is, then let's swap wallets, okay? Because, or what we'll check first. That's false. So my test point's right here where the tip of my pen is, where that black dot is. I got a false statement. So where am I going to shade? If you picked 0, 0, which is my default test point, then you got a true statement this time. And so you already knew to shade on this side. So there we go. There's my extensive shading. I was great at coloring in kindergarten. All right, if you have questions, ask them. If not, flip the page. I just wanted to be thorough, so we just have a couple more problems we're going to do just to keep reviewing this. Notice, I'm sure you're proud of me. The example numbers go left to right this time, so I won't confuse myself. Do example, or excuse me, exercise 3. Again, if you need me, raise your hand. I'll come to you. All right, so step one, my boundary is 3x minus 2y equals 10. So we'll rearrange this by doing a little subtraction and getting negative 2y is equal to negative 3x plus 10. Then we'll divide everything by that negative 2 right there. And I get y is equal to a negative 3 over negative 2. That's positive 3 over 2x. And then 10 over negative 2 is negative 5. Okay, slope 3 over 2. Y-intercept is 0, negative 5. Okay, so hopefully we're getting to be old hat finding slope and y-intercept. That's going to be a big component of the test that you're going to take on Tuesday. So 1, 2, 3, and then 2, and then 1, 2, 3, and then 2. And we could keep doing that, but we don't need to. I'm going to connect those dots, and I'm going to do what kind of line? Solid. Again, there's an equal here, so I'm going to use a solid line. The boundary is part of the solution. That's what that solid line means. And now I need to know where are the other solutions. So I'm going to pick a test point. I'm going to pick this time 0, 0. You got me exhausted using all these other points. Okay, so 0, 0, whatever you picked, our conclusions will be the same. You will not get a different conclusion than me if you used a different point. So I've got 3 times 0 minus 2 times 0 is greater than or equal to 10, I want to know. So that's 0 minus 0, or 0 is greater than or equal to 10. Is that a true statement or a false statement? That's false. So my origin, where the x and the y cross, that was my test point. I got a false statement, so we shade below it. Again, just to reiterate a point I made earlier, I know you want to, we all want to. We want to skip steps, and you want to see this greater than, and you're, oh, greater than, I'm going to shade above the line. Okay, well, you're going to be right half the time. Okay, so if you want your grade to be right half the time, that's fine. But notice on this one's greater than, we shaded below the line. Okay, so just keep that in mind as you're doing that. All right, one more problem like this. Exercise 4, 4x plus y is greater than or equal to 0. Very exciting. So my boundary is going to be 4x plus y equals 0. So when I solve that for y, this is nice. I just do one step. I subtract that 4x, get y is equal to negative 4x. So the slope is negative 4 or negative 4 over 1. That's clear. Maybe you weren't too clear on this one because I think the first time it's happened in class. What's the y-intercept of this line? 0, 0. Yep. There's no number there, so that's 0, so meaning the origin. That's why I gave this one. I just want to make sure that we were comfortable picking a test point. So 0, 0, my slope is negative 4 over 1, so that's down 4 and then over 1. So I'll do that, down 4 over 1. Great. Solid or dotted line? Yep. The boundary is just the boundary. It separates the Cartesian plane on this one, but it is not part of your solution. It's the same thing as an open circle on the number line. It's the boundary. You can get as close to that boundary as you want, but just don't equal it. And then the third thing, 0 zeros out as a test point. My line goes through 0, 0. You can't pick a point on the boundary. So give me another test point. I heard somebody over here. What'd you say? Somebody said 1 something. 1, 1. Sounds great. It was just the first thing I heard. That's why I picked that. I'm not playing favorites. All right. So then 1, 1 is what we're going to test. 1, 1, Perkster. There we go. So I put a black dot there just to show what side of the line it's on. So if I get a true statement for 1, 1, I'm going to shade the same side as the black dot. If I get a false statement for 1, 1, I'm going to shade the opposite side of the black dot. So here we go. My inequality is 4 times 1 plus 1 is greater than 0. That's 4 plus 1 or 5 is greater than 0. That is a true statement. So that means I'm going to shade on the same side as the black dot. Woo. Are we feeling okay? Okay. Bored means okay. That's fine. All right, a couple more. I want to make sure that, again, part of today is just making sure I'm reviewing some big concepts that we've talked about before. So these next 2 problems review a couple of special lines that we've talked about in the past. So go ahead and give your best effort to exercise 5. Graph that inequality. Now these special cases, you can be a little quicker. You don't, in all honesty, you don't need to pick a test point. It's the same thing as the number line. Okay, you can pick a test point. It'll all work out. But give it a try. All right, so when I write down my boundary is y equal 4. Now back in section 2.1, I just made a recommendation to you. I said this is one of the 2 lines. I would just recommend remembering what it is. What kind of line is y equal to 4? It's horizontal. So I'm going to do a horizontal line at the y value 4. So here's the y value 4. I'll put a dot there. Am I going to draw a solid or a dotted horizontal line? This one's going to be dotted. There's no equal. Again, this horizontal line represents the boundary, but it's not part of the solution. And then it's a horizontal line. You don't need to test the horizontal. And then the next one, when we do, there's not going to be much surprise there. So which side of that horizontal line represents the side with the y values that are less than 4? Is it going to be above that line or below that line? Yeah, below. And you can see on the graph, I have some of them marked. So 0 and -5 and -10, those are below. So those are less than 4. So I'm going to shade this side right here. Does that make sense? All right, well, some of you probably already have or are working on it. Exercise 5, very similar. Again, it's just review, making sure that we remember these 2 special cases. So my boundary in this case is x equal to 8. And x equal to 8 is an example of what kind of line? Vertical. Just as an aside, it's not necessary for this problem, but I'm just trying to be thorough. What's the slope of a horizontal line?
0.
I said horizontal, but you were looking at that problem. So maybe you were thinking that horizontal, what's the slope of this horizontal line? Rise over run?
0.
0. There's no rise to a horizontal line, so the slope is 0. The vertical line, which we were looking at, so sorry to goof with you. The vertical line, what's the slope of that? Undefined. There's no run. The denominator is 0, so it's undefined or no slope are the right answers there. So at the x value 8, so 6, 7, 8, here's the x value 8. I'm going to make a vertical line. I am pretty sure we would all say that that's going to be a solid vertical line because there's equal. So my vertical line is part of the solution. And then again, vertical and horizontal, pretty straightforward as far as shading. Which side of the vertical line represents the x values bigger than 8? Is that going to be left or is that going to be right? The one's bigger? I heard somebody say left. Left is, now if you're like me, I don't know my left from my right. Anytime I say the word left, I make my L with my hand. So just so little secret into the mind of the perkster. Okay, so I am not confident. So maybe you made that mistake. These numbers here, 5, 0, -5, -10, those are smaller. Those are not bigger than 8. So I'm going to shade over here on the right side of the line. That's where the x values are bigger than 8. All right, again, we're almost done. There's nothing new. From here on out, there's nothing new. We're just going to combine our skills into one last thing, and we're going to talk about compound inequalities and graphing them. We're going to do some and statements. This is going to help us for when we come back to Unit B later next week. We talk about solving compound equations. But for now, all we're going to do is graph. So when you see a compound inequality, all you're going to do is you're going to the general thing is you're going to graph both of these inequalities, and then you're going to see where they overlap. So again, because I'm fundamentally lazy, I picked 2 inequalities that I've already done. So I'm going to get my data from the front page. The first one is -5x plus 2y is greater than 4. So from the front page, that's the very first problem we did. The slope of that is 5/2. The y-intercept is 2. So I was just saving us all a little time so that you didn't have to watch me do something that I think you're catching on to. I'm hoping you are. So slope of 5/2, y-intercept of 2. So here we go. Y-intercept of 2, slope of 5/2, 1, 2, 3, 4, 5, 2, 1, 2, 3, 4, 5, 2. And then we connected that with a dotted line because there's no equal. I'll give you a moment to catch up. I don't want to rush ahead of you for something that should be no more difficult than what we've already done. And then again, I'm just flipping to the front page, and then we shaded because we picked a couple different test points. We shaded to the left of this line. So here's my nice pink shading for this line right here. Whee! I'm just reproducing my first problem. I just picked lines we've already done to save us a little bit of time. And now the next one is y is less than 4. We just did that on the previous page, but it's not too hard to reproduce. The boundary is a horizontal line at the y value 4. So I'll make a little dot there. It's going to be dotted like it was on the previous page. You can turn your sheet back to the previous page. And then the y values less than 4 are going to be the y values below. The y values get smaller as you go down. So here is my shading. I'm going to give you a moment to catch up, okay? Because I know I just reproduced both of those pretty quickly. I don't want to lose anybody on this next part. So now that we've done that, now that we've graphed both of those lines and we've shaded them, now when you do a compound inequality, this is the thing I will look for though, okay? So nothing has been new other than we've done 2 graphs on the same grid. Now I want to know what points are the solution to both of those. So I'm just going to point to the region and you're going to say yes or no. Are these the solutions to both? So up here where my pen is, are those the solutions to both? No, in fact, those are the solutions to neither. How about this pink part? Solutions to both? No, how about this right here? Solutions to both? Yes, I'm going to keep my finger there. Here, this green part, solutions to both. Now, then all I'm going to ask you to do when you take the test is to go ahead and shade this darker, or I have a different color because I knew we were doing this. So if you can just shade it darker or draw an arrow and say that region there is the solution, just in some way, if you can notate for me where the two regions overlap, that is the solution to my compound inequality right there that I have scribbled black ink in. All right, so we've got plenty of time to finish up these two problems. We don't have to rush. If you need me, raise your hand. I'm going to give you 3 or 4 minutes, exercise 7. If somebody happens to be watching this video, I'm going to push pause so you don't have to watch 3 or 4 minutes of silence. We'll save a little bit of bandwidth. So once again, if you're watching the video, I'm getting ready to do this problem, so you might push pause on your video just so that you can stop and finish up. So here we go. I tried to make these a little bit easier on this first problem. So this first one, there's not a whole lot. When you go to look at the boundary, it's y equals 2x minus 3. I've already solved that for y. That was intentional to save you a little bit of time. So my slope is 2 or 2 over 1. And then the y-intercept is 0, negative 3. Okay, so 0, negative 3 is down 3, 1, 2, 3 right there. That looks good. And then 2 over 1, 1, 2 over 1, 1, 2 over 1, 1, 2 over 1. And we'll connect that with a solid line. There's an equal on that bar. And so then the last thing I will do is I'll pick a test point. I'm going to pick 0, 0 because it's not on the line. So I'm going to test 0, 0. So again, anything you picked is going to be fine. We'll come to the same conclusion. So when I put in 0, 0 into the inequality, I get 0 is less than or equal to 2 times 0 minus 3. 2 times 0 is 0, so I just have minus 3 or negative 3 over there. Is 0 less than negative 3? Indeed not. So my test point was right here. I got a false statement. That means the solutions are on the opposite side as the test point. So there's my first bit. Any questions about that? Anything you overlooked? I'm going to put 2 of these problems on the test that you take next class. Okay, so hopefully you're finding it okay. Y is greater than or equal to negative 5. So the boundary is y equals negative 5. So that is a horizontal line at negative 5. So here's negative 5 right here. Again, it's going to be solid because there's an equal bar. And I want the y values bigger than or equal to negative 5. So I'm going to ask this question just because I'm not feeling super comfortable about our consensus. Which way am I going to shade, up or down for greater than negative 5? Up, yes, okay, a little bit better. Still not like super amount of participation on that question. That's okay. All right, and so then the last thing you're going to do for me is you're just going to shade darker or draw an arrow and point me in the right direction. Where's the solution? And hopefully we can all identify that right here where my black pen is, this region is the one that's the solution. So the shading's going to look something like this. My problem with shading and coloring is I just get impatient. Look at me, just doing a great job here. Beautiful. Yes. On this one right here? Okay, so I want the y values that are bigger than 5. So bigger than means negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, things that are bigger than negative 5. My y values are represented by this axis that goes up and down. Okay, so notice on the axis here is the horizontal line at negative 5. The y values are going to get big. I'm not looking at the x values. I'm just looking at the y's. I'm just looking up and down. If I go down, these values are less than negative 5. Negative 10, negative 20, negative 100. These are more negative. They're less than negative 5. So when I go up, I get the positive values. I get the values that are bigger than negative 5. So that's why I shaded up in that case. Okay, a little better? Okay. Any other questions? All right, last problem for the day and for the week. Again, I'm going to give you 3 or 4 minutes to make as much progress as you can on exercise 8. Once again, if you're watching the video, I'm going to push pause. So push pause on your screen and give the problem a go. Okay, so let's finish up the last problem for the day, and then we will we'll make our way. So here we go, last problem for the day. So the first one, I'm just going to do x minus y greater than or equal to 2. My boundary is x minus y equals 2. I'm going to solve that for y. You're welcome to graph that using the x-intercept and the y-intercept. It doesn't matter. I'm just kind of getting the habit of solving for y. I'm going to divide by the -1, and I get y is equal to a negative divided by a negative is a positive x, and then a 2 divided by a -1 is -2. So I see that my slope is 1, which I'm going to write as 1 over 1. So I have a rise and a run. And then my y-intercept is 0, -2. So 0, -2, I go down 2. 1 over 1, so up 1 over 1. We could do this all day, very relaxing. I'm going to connect those dots with a solid line. Anybody want to suggest a test point for me? Okay, yes, why not? Appreciate you affirming what I like. Okay, so 0, 0 sounds good. Again, my 0, 0, I'm going to put a little black dot right there. And so if I get a true statement, I'm going to shade on the same side as the black dot. If I get a false statement, I'm going to shade on the other side. So let's see what happens. I get 0 minus 0 is greater than or equal to 2. Well, 0 is not greater than or equal to 2. That is a false statement. So my black dot's right there. I'm going to shade over here. All right, first part of this is done. The second part of this is the line x is greater than or equal to 3. So my boundary for this is x equals 3. And you said earlier that that is a vertical line. So at x equal to 3, which is purple dot right there, x equals 3 is right there. So nice solid purple line. Whee. And just like the number line, which ways do the x values get bigger? Where it's bigger than 3? Am I going to shade left or am I going to shade right? I'm going to shade right. Okay, so this way right here are the x values. All of these points that I'm shading purple, if you listed out their ordered pairs, they have an x value that's bigger than 3. So the last thing to do then is to go ahead and say, oh, these two things overlap right here at this bit. For as big as the Cartesian plane would be, that goes on forever to be this region. And there we go. Before you pack up, I got a couple last things to say. So give me a minute to finish my coloring. Don't rush me. There we go. Oh, beautiful coloring. Love that.